So what are we doing with vectors? Well, first of all, what is a vector? A vector is different. There's basically, when you start getting into the sciences, we come up with what are called vectors versus what are called scalars. Now, scalars are numbers, and the word that we often use is they have magnitude. Magnitude is a fancy word for what? You guys never heard that word? What's it mean? Who has magnitude on the Browns? The lineman or the kicker? The linemen have size, right? That magnitude is a fancy word for size, really. Okay? Well, numbers, who has more magnitude, 15 or 28? Okay. Who has more magnitude, 1 or negative 45? Well, that's an interesting question. It turns out negative 45 is going to have more magnitude. The magnitude, you might say, is going to be the absolute value of the number. Okay? But somehow we're measuring size with if I say that, what's the smallest magnitude you could possibly have? 0, right? Give me a number that has a magnitude of 0. 0, right? The absolute value of 0 is 0. The absolute value of negative 3 is 3. The absolute value of 2 is 2. So magnitude is going to mean absolute value if we're talking about scalars. But when we talk about vectors, vectors have both magnitude and, what am I going to say? I heard it. Direction. That's right. Now, it's kind of funny because we've just been graphing in polar coordinates, r and theta. Which one of those corresponds to direction? Isn't that true? Wait a minute. R doesn't correspond to direction. Which one corresponds to the aiming, the direction? For r and theta. Now let's go back to what I just did. The first thing we plotted was theta, aim. That's your direction. R is going to be the magnitude. Does that make sense? Really, this is my magnitude. And really, when I aim, I'm really thinking about direction. Okay? So when we talk vectors, we're going to be talking magnitude and direction. Okay. Now, the way we're going to represent vectors, I've already shown you. I gave you the sneak preview. Matter of fact, go ahead and look at these examples that they give in the book. I think we'll do, well, yeah, number one's a great example, but did I assign that one? Let's see. Yeah, I did. So let's do number 4, I think would be a fine example. All right. So number 4, the first vector v, they give me, they put it in brackets, and they put 10 and 4. And by the way, you'll know that we have a vector sometimes if we have those strange parentheses, those brackets. And you'll also know if we have a vector because they'll put a little arrowhead above the letter that represents it. So Dr. Stitz is using V and W. A lot of books use X and Y, but they'll put either they'll put an arrowhead above usually, or they might make it bold-faced or something. Okay. But it turns out that you can plot vectors. Okay? So watch how this works. If I want to plot 10, 4, Well, I get out my graph paper and I count over 10. And I tell you what, let's say that each of these lines represents 5. How about that? So here's 5, here's 10. So there's 10. And if I go up 4, well, that line would be 5. So let's say that V, see that point 10 comma 4? V is the vector starting at the origin and ending at the point 10 comma 4. So this I'll label as the vector V. You want to start at the origin when you draw the vector. Does that make sense? Here, you tell you what, I'm going to pause. Why don't you guys try to plot on the same picture, start at the origin, and see if you can plot vector W. Yeah, so I said that each line represents 5, right? So here's 5 and here's 10. So when I go to do W, oh, which quadrant is W going to end up in? Quadrant 2, that's right, because I have to go to the left 2. So here, I'll do this one in red. I'll go back over here. Well, that's 5. That's too far. That'd be negative 5, right? We want to go to negative 2, and then we want to go up how many? 5. Okay. So W, if you did it right, you should get this vector right there, W. How many people understand how to plot a vector from these coordinates? Is that okay? Question, Melanie? No? Okay, so that's not hard. Now it turns out that just like the numbers we've been using so far are scalars. We just never had that name. But when you have vectors, you can visualize them. See? Because they have 2 dimensions in this case. Although you can also have 3-dimensional vectors. But not in this class. Okay. It's not any harder, actually. But what we're going to do next is we'd like to do things to the vectors. So for example, we can add vectors. So if I want to add V plus W, any idea how I might do that? And you might say, why do you want to do that, Paul? Why did you skip 3 sections to go to this? What's so special about vectors? See, vectors appear everywhere in science. For example, suppose you're standing at the origin. This is a map on Google Maps. Actually, see that origin? That's my bald head right there. It kind of stands out, right? It's shining. So, anyways, standing with vector V, Tyler has a blue rope attached to my waist. Do you guys see it on the map? Okay. Nikki has a red rope attached to my waist, and they're both pulling. I'm being pulled that way. I'm being pulled. You guys see that? Now let me ask you, if they both pull, by the way, who's pulling with greater magnitude, what did you say? Tyler, I don't know, maybe he's stronger than you, Nikki. I don't know, offense, but do you see that? How many would think that the magnitude of V is bigger than the magnitude of W by looking at it? And we're going to compute it, and we're going to see that it is. We're going to compute it today, and we're going to see that it is. So when they pull me, my question is, where am I going to end up? Where am I going to end up being pulled? And that's what I'd like you to talk to each other about for a second here. And if any of you say I'm ending up in quadrant 3, just get out of here. Go home. All right, where am I going to end up? Quadrant? Yes. Now let me show you exactly where I'm being pulled. It's beautiful. What I'm going to do is I'm going to take vector V, and instead of starting at the origin, I'm going to start at the end point of vector W. We say tip to tail. It turns out you don't have to start at the origin when you draw a vector. Although I like doing that to start. Or another way to do it is I could take vector W and slide it so that we're going again, tip to tail. Do you see where I'm going to end up? Matter of fact, let me draw it. This vector, kaboom! That's where I'm going to get pulled. You guys that said I'm going to get pulled into quadrant 1, you're correct. That's the sum of these two forces. Now, if I brace my feet, maybe I won't be pulled. But that's the force being, it's the sum of the forces v and w, of the vectors v and w. And so, can we figure out exactly what that vector is? V plus w. Wouldn't it be great if the rule for adding vectors was, like, what do you think the first one should be? 10 plus negative 2 is 8, and 4 plus 5 is? Wouldn't it be great if that were the rule? It is. Isn't it? Look, 8, 9. I think I made it too thick. It looks like it's hitting 10. But are you guys with me on this? If you want to add two vectors, you just add the coordinates. Isn't that beautiful? All right. So now there's some other things you can do. You can multiply by a scalar. We can multiply by a scalar. We can also multiply by a scalar. So, for example, on the homework problems, hey guys, look at the very first thing they're going to have you compute. V plus W, right? They're going to have you compute V plus W, so you'll know how to do that. The very next thing they say is W minus 2V. Well, that's kind of strange. Let me show you how you do it, though. So, for example, let me draw for you 3W. Well, all that means is W plus W plus W. Could you guys figure out what that is? What is it? Again, what is W? It's
6.
Oh yeah, it was negative 2, comma 5, right? And we're going to add that to itself 3 times. So what are we going to get? Negative 6, comma 15. And sure enough, you could see it on the picture. If you had 3 of these things, you would be at negative 615. I think it's really nice to do it on graph paper and do it algebraically. So to multiply by a scalar, do you see how it's almost like distributing? Okay. So all the rules are still going to work. They're going to ask you to do, what do we say? It was W minus 2V. W minus 2V. All right. Well, how do I do that? Well, let me fill in what I know. I know that W is negative 2, comma 5. Minus 2 times 10, comma 4. And so, just like we distributed the 3, you could distribute what? You could distribute the 2, or you could distribute negative 2. And if I do that, it's going to be negative 2, 5, plus negative 20, negative 8. Okay? And so I guess the answer to this one is negative 22, comma negative 3. And I don't feel like drawing that. Is that okay? All right? But again, this is the kind of thing you want to be able to do, algebra. Now, I mentioned magnitude. So, for example, the symbol for magnitude, by the way, is 2 bars. Suppose I say, let's find the magnitude of W. In other words, let's figure out how long is W, right? So, again, that's the magnitude of, well, the vector negative 2, comma 5. So if you want to find that, well, that should be easy from the picture, right? Here, let me zoom in on the picture. the picture was this. We had the x and y coordinates. We had a vector going this way we called W. Let's draw a triangle. -2 and 5. How am I going to get the magnitude, guys? Sure. Actually, remember I said another way of thinking of it is it's the same as R. So this is going to be the square root of what? -2 squared plus 5 squared. Jordan, you okay? Okay. So I get the square root of 4 plus 25. I get the square root of 29. Is this all right? Easy? Okay. Matter of fact, just to test and make sure you guys are okay with this, could I have everybody work together and find the magnitude of V? We said Tyler had more magnitude on his pole. We'll see. Could everybody find the magnitude of V while we're waiting? Last little bit, because we're almost out of time, and last little bit because, I'll tell you what, you guys have used an entire legal pad this year for notes. Got to get a new one for next class. I have this much I could possibly teach you. All right? And I have 3 minutes, so this is working out just nice. All right, so ready? We just talked about magnitude. What's the other thing I need to tell you about? Direction. That's right. How do we express the direction of a vector? And I was trying to find a good example. I like thinking about number 33. 33. Okay? So 33 says, hey guys, here's your vector, 5, 5. So let's plot that vector. And again, I decided to make each of these lines be 5. So that means I'm going to go over one line, I'm going to go up a line, and so my vector is that. Correct? Okay. Now, what we're going to do when we start talking about the direction of a vector, remember the magnitude is like R, right? Because look at what R is. R is the square root of x squared plus y squared. What do you think I'm going to be doing here for direction? Theta, the angle. That's right. This angle theta is going to represent the direction. What angle is that? If I'm pointing at the point 5, 5, what is it, Anna? 45 degrees. But let's work in radians. What is it? Pi over 4. You guys with me? That theta equals pi over 4. That specifies the direction. Now, I guess what you need to know here, okay, is that there's an equation. Vector V equals magnitude of V times cosine of theta, comma, sine theta. This is a little weird. This is a vector. When you take the magnitude of something, do you get a vector or a scalar? Like square root of 29, what's that? That's a scalar, right? So this equation says, hey, another way of writing vector V is take its magnitude and multiply that by cosine theta, sine theta. Now, what is the magnitude of V? Let me check that. I could do that pretty quickly. Good thing, because I'm down to 1 minute. Square root of 5 squared plus 5 squared, right? Isn't that square root of 50, guys? Okay. What's the cosine of pi over 4? You guys know that. Square root of 2 over 2. What's the sine of pi over 4? Square root of 2 over 2. It's also called 1 over square root of 2. But it turns out that if you multiplied these together, you know what you would get? It says we'd get v. If you multiply these together, remember we kind of distribute, you're going to get the vector 5, 5, just like I said. So this equation is how the direction and magnitude are related to the original vector. All right, we're out of time. Nice work today.